Hello, grade 8s. We're into our next topic on looking at linear equations and table of values and finding the patterns associated with them. So as we get into it, we're just going to go over a little bit of vocab that may or not be new to you. The first term is variable. So this is just some type of letter or symbol that represents a number that we don't know. So if we look at this expression for a minus 7, a is the letter, it is our variable in this situation. The second key term is expression, and this is just, could be...
Hello, Peter. If you're around, can you please come down to the office? Thank you.
Could be any single number or variable or combination of the two, including any of these operators, plus, minus, times, and divide. And key thing is here is there's no equal sign in an expression. So I've got a couple examples of expressions for you. 4, even the number 4 by itself, is an expression. D, a variable by itself, is also an expression. 9f, which just means 9 times f, is also an expression. C plus 11, 7b minus 5. These letters and numbers and variables and operators can all be combined, and as long as there's no equal sign, we can call that an expression. Okay, so what we're going to be doing today is looking at some of these patterns. We're going to be graphing them, and we are going to be writing some expressions at the end. So if we look at this table of values right here, our first task is to graph these ordered pairs. And so here's my x-axis and here is my y. I'm going to make my x's go up by 1, so that's 1, 2, 3, 4, 5, and I'm going to make my y's go up by 5, 5, 10, 15, 20, 25, 30, and then I'm just going to plot these coordinates. So 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, 6, 30, 7, 35. Okay, so the next question here. B, what is the difference in value for consecutive x values? So consecutive just means one after another as I see them on this table of values. So the difference as I go from 1 to 2 is 1. As I go from 2 to 3 is 1. Every time I look at my x values, they're always going up by 1. So the difference as I move up is just 1. So I'm just going to say x values go up by 1. What's the difference in value for consecutive y values? 5, 10, 15, 20. It looks like my y values are going up by 5. Describe in words the relationship between the x values and the y values. So I might even use a combination, or I might just put these two ideas together and say something like, if I'm talking about question C, as my x values increase by 1, my y values are increasing by 5, and that describes the relationship between the two. I'm not going to write that down. Hopefully you were able to listen to me just now say that. D, what's an expression for y in terms of x? So let's say I'm only given the x values. How can I come up with the matching y number? And so let's say if all I knew about this coordinate pair is that x was 1, how am I getting this 5? I would guess that I'm multiplying by 5. As I look at the relationship in this pattern, it looks like if I multiply any one of these x values by 5, I get the matching y value. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. So my expression for y in terms of x, or when I can only write x, is 5x. Again, I'm just creating an expression where I can come up with the y number, where I can come up with this number just based on the x number. That's all I'm doing there. Okay, so in terms of linear relations, there's two things about them. There's two ways we can tell if a relationship is linear. The first way is, as we talked about in our last topic, it's got to form a line. If we graph the ordered pairs, if they form a line, the relationship is linear. Another way that you might be able to tell just by looking at a table of values is if consecutive x values increase by some amount and the same amount, and our consecutive y values increase by the same amount or decrease by the same amount, they could increase or decrease, then that's another way that we could say that the relationship is linear. So, in terms of where you might see a question like this is like this one here. We're given two table of values and we want to decide which one of them could possibly represent a linear relation. And so this says check by graphing. If I plot table 1, I'm going to have here's my A values are going to be on the x-axis, B values on the y. I'm going to go up by ones, so that's a 1, 2, 3, 4, whoops. This would be 6, and then 8. And then I'm going to make my B values go up by 2. Each space is going to represent 2. So 2, 4, 8, 12, 16, 20. That gives me enough room to plot everything. Okay, so my first value is 1, 1, which is right here. 4, 10. And then a 7. This is 18, 19 is right there. So this relationship, we can only say if it's linear or not if we can take a ruler and draw a straight line through all of these points. Can I do that in this case? It looks like that is going to be possible. A straight line went through all of these points. Okay, my next one, I have some relationship between P and Q. Again, I'm going to go by ones, 2, 4. I don't want to label every single space, so I'm just skipping here. I'm going to do the same thing here. I'm going to go up by ones, I guess. So it's a 2, 4, 6. Okay, I'm going to plot the points. 0, 0, 1, 1, 2, 3, 3, 6. So, can I draw a line through all of these points? Looks like I can almost get 3, but I cannot get this last one. And so, since I can't draw a straight line through these points, this is non-linear. Draw a line through it, it's linear. Can't draw a line through it, it's non-linear. It's a non-linear relationship. That is one way you can tell. Alrighty, that is all for now, I believe, that I need to share with you. Take care.